Hello everyone, now today's question is if S and H be the foci of an ellipse, any point A be taken on the curve and the chord A as B, B as C, C as D and D as E be drawn in any ellipse, eccentric angles of A, B, C, D and so on are theta 1, theta 2, theta 3 and so on. Now we need to prove that all these values are equal. The values are tan theta by theta 1 by 2 multiplied by tan theta by 2 is equal to cot theta by 2 cot theta 3 by 2 and so on. So let's start with the basic ellipse x square by a square plus y square by b square is equal to 1, and commonly we take a greater than b. That means the major axis will be x-axis and minor will be y-axis. Now let's say this is our x-axis, y-axis. Let's say this is our ellipse. Let's say you take any point a point here. The parametric, you can say theta 1, or you can write the parametric coordinate. The eccentric angle is theta 1. The parametric coordinates are a cos theta 1 comma b sine theta 1 here. Similarly, you can take one more point. So let me define the first of all the focus here. The focus is given S and H. So let's say this is our first focus S, and the coordinate of S is AE comma 0 here. And now one more focus is there, that is H. So let's say this is H and this is minus AE comma 0. Now through this point we have drawing a chord here joining A and B. Let's say this is our B point, and the eccentric angle of B is theta 2, and the parametric coordinate will be A cos theta 1 theta 2 comma B sine theta 2. Now before proving these values, I need to do one thing that is very important. We should know the equation of the chord AB. So I'm going to write equation of line, or you can say chord joining AB. So you should know in the terms of theta 1 and theta 2. See, we have the 2 points here. Clearly we have the 2 points. We can calculate using 2-point form. If you calculate using 2-point form, you should remember for JEE Mains and JEE Advanced, this result is very frequently used. So the equation of the line is x by a cos theta 1 plus theta 2 divided by 2 is plus y by b sine theta 1 plus theta 2 divided by 2 is equal to cos of, you will get here, theta 1 minus theta 2 divided by 2 here. Now they are saying the first chord is passing through S. As it mentioned here, A as B. It's mentioned A as B is the first chord. So A as B is going to pass through the first focus here. That is A comma 0. Now if I put this, if it's passing through this point, I'm going to substitute this point. The moment I substitute, this value will be 0 here. And here we'll get this as E times of cos of theta 1 plus theta 2 divided by 2 is equal to cos of theta 1 minus theta 2 divided by 2. Now from here I can write this as cos of theta 1 minus theta 2 divided by 2 whole thing divided by cos of theta 1 plus theta 2 divided by 2 is equal to E. Let's say this is our first equation. Now here, in order to get tan theta 1 by 2 and tan theta 2 by 2, it's given in the question, I'm going to apply componendo and dividendo, and commonly we call this as compendio. Now applying componendo means adding denominator and numerator. So we'll get cos of theta 1 minus theta 2 divided by 2 minus cos of theta 1 plus theta 2 divided by 2. Now dividendo means I'm going to here subtract denominator from numerator. So we'll get cos of theta 1 minus theta 2 divided by 2 minus cos of theta 1 plus theta 2 divided by 2. Now this will be equal to, now the same thing I'm going to do in here, you can consider denominator 1. So we'll get E plus 1 upon E minus 1. Now I'm going to apply cos C minus cos D. So if I apply cos C minus cos D, I'll get 2 cos C plus D by 2. I think we'll get cos of theta 1 by 2, because theta 2 and theta 2 will cancel out here, and cos of D minus C or C minus D by 2. So you'll get this as theta 2 divided by 2. Whole thing divided by, you will get this here as 2 sine theta 1. Here I'm going to apply cos C minus cos D, that is sine C plus D by 2 sine D minus C by 2. So you'll get 2 sine theta 1 by 2 sine theta 2 by 2 is equal to E plus 1 upon E minus 1 here. Now here 2 and 2 will cancel out. Now I'm going to write a generalization here. If any chord is passing through, you can say focus, and the chord endpoints are A theta 1 and B theta 2. So directly you can write from here, that is you can write tan theta 1 divided by 2 multiplied by tan theta 2 divided by 2 is equal to, you can write, as you can see, tan theta is coming in denominator. So if I take reciprocal, I'll get e minus 1 upon e plus 1 here. So this is one generalization. That is, if the chord is passing through one of the focus, that is AE. So you can write the result for any ellipse you can write. So this is it is passing through AE comma 0. Now I'm going to give you one more generalization, that is, if any chord is passing through the other focus was, I think if you remember, the other focus was H here, that is minus AE comma 0. So for that minus AE comma 0, I can write this as, see here, only difference will be a negative will be introduced here, the only difference, because if I substitute any point, that is minus AE comma 0, a negative will come here. So you will get the same thing, tan theta 2 divided by 2, and then tan theta 3 divided by 2 is equal to, you will get the same thing, but in reciprocal you will get. So e plus 1 upon e minus 1 you will get here. This is one more generalization you have to remember. Now I'll show you what the points are, theta 2 and theta 3. In the previous diagram, from this point, from B point, if I connect to one more point, let's say D point is here, somewhere here, D point, or let's say C point, the eccentric angle is theta 3. That is A cos theta 3, B sin theta 3. If you connect with the other point, B, that is theta 2, then you can write for this line you can write tan theta 2 by 2, tan theta 3 by 2. Here you can write e plus 1 upon e minus 1 here. So these two results I got. Similarly, if in the previous diagram, if I connect one more let's say chord, as they are saying, because we have more eccentric angle, and as you can see, this is the reflection property of the ellipse also. If the outer surface is polished, then this chord which is passing through the focus will be reflected towards the other focus. So I think we'll get one more line here. Let me show you. So we'll get something like this. And if this point is D point theta 4, so for this point you can write here, for theta 3 and theta 4, this chord which is passing through AE comma 0, you can write tan theta 3 by 2, tan theta 4 by 2 will be equal to E minus 1 upon E plus 1. Again you can write. So let me write in a generalized format. So here I've generalized that any chord which is passing through AE comma 0, one of the focus of the ellipse, and the endpoints are A theta 1 and theta 2. Here theta 1 and theta 2 are the eccentric angle. So in this case, the tan of product of the angles will be equal to E minus 1 upon E plus 1. Similarly, if the chord joining theta 3 and theta 4, that is obviously going to pass through AE comma 0. I can show you in the diagram also. As you can see, the chord joining theta 3 and theta 4 is passing through AE comma 0. So again, this result is valid, that the product of the tan of the angles will be equal to E minus 1 upon E plus 1. On the other end, if the chord is passing through minus AE comma 0 and the endpoints are theta 2 and theta 3, so we can write the same result. The only thing that is going to change is, with the negative sign, this is going to change, and that will be reciprocal of the previous values. So suppose I want to equate these two values. So if first value is alpha, then the other value will be 1 by alpha. So can I say these product of tan of angles are equal to reciprocal of this tan of angles? That means, can I say the product of tan of this angles are equal to cot of this angles, because reciprocal of tan will be cot. Now I can show you the actual proof. What they wanted is the tan of theta 1 divided by 2, theta 2 divided by 2. That thing, this chord is passing through AE comma 0. So this value will be equal to, as you can see here, E minus 1 upon E plus 1. Similarly, this chord which is containing the endpoints theta 2 and theta 3, it's passing through minus AE comma 0. Now this value of the chord will be E minus 1 upon E plus 1, and both values are equal. Similarly, theta 3, theta 4 chord will pass through AE comma 0, and again this value will be equal to E minus 1 upon E plus 1. So this pattern will repeat in tan and chord. So we have to remember this result. That is very important. And based on this result, one more question is there. So I'll show you that question. This question. Now this question is based on the previous question proof. If you understood everything in the previous question, you'll be able to do it. So this question you need to try. If you don't get it, there's no worry. I'm going to take this as a question number 2 for ellipse series, and I'm going to solve in the next lecture. So if you try this, you'll definitely enjoy this question, and that'll be all.